So FD, we know that FD is nothing but polynomial in D. So we will consider FD as auxiliary equation. So we will find auxiliary equation to find YC. Remember, we are finding the complementary function. So for complementary function, we will find the auxiliary equation. The auxiliary equation is nothing but f of D. From here, f of D, we equate it to 0. So this will be the complementary function. Since our FD is a polynomial, so it will have some roots. Okay, so it will have roots dm minus 1 one root, dm minus 2 the second root, dm minus 3 the third root, and if its power is n, so d minus m n roots equal to 0. So in this, whenever we have roots, we have again 3 subparts. When roots are real and each root is different, that is distinct. So this is d minus 1, this is d minus 2, d minus 3 up to d minus 100. So as you can see, in each part, in each of the root is different. So the roots are real and distinct. Then our YC is given by C1 e raised to m1x plus C2 e raised to m2x, where m1 and m2 are roots of this equation, plus C3 e raised to m3x, and so on. When roots are repeated twice, let's say our root m1 repeated twice, so it will be something dm minus 1 and dm minus 1. The complementary function in this case will be C1 e raised to m1x. The first part will remain the same, plus C2 e raised to m2x instead of m2, because the roots are repeated. So here it will again m1. When we are writing e raised to m1x, e raised to m1x twice, then we have to multiply any one term with x. Okay, so this can be modified as c1 plus c2x into e raised to m1x. I am taking e raised to m1 common. So these are the roots repeated twice. When the roots are repeated thrice, what will be the complementary part? So d1 minus m1, d minus m2, and d minus m3. So here the roots are repeated thrice, so this will be m1 and this will also be m1. So in this case, the complementary will be given by c1 e raised to m1x. You will write the same thing for e m1x and c3 e raised to m1x. First you will write these things as it is, as we used to write for this. Now since m1 is repeated thrice, here it is also m1, here it is also m1, here it is also m1. Okay, so now when it was repeated once, we have multiplied by x square. Now it is repeating thrice, so first we will multiply by x in one term, and in another term we will multiply by x square. Okay, so if the roots are repeated thrice, we will multiply by x and x square in two terms. So here we have multiplied by x and here we are multiplying by x square. When the roots are repeated twice, we are multiplying only by x in one term. So when the roots are repeated 4 times, then we will multiply by x and x square and then x cube. So the power of x keeps on increasing. So when the roots are repeated 4 times, our equation will be something like this: c1 plus c2x plus c3x square plus c4x cube. And from all this term we can take e raised to m1x common. Okay, so this will be the solution for complementary part. So we have seen the roots are real and distinct and roots are repeated. We will have one more condition when roots are imaginary. Okay, when the roots are imaginary, say our roots are alpha plus minus beta and these roots are distinct, that is they are occurring only once, so they are non-repeated roots. Then our solution of complementary becomes yc is nothing but e raised to, so this is alpha is the real part and beta is the imaginary part, e raised to real part into x into cos of beta x into c1 plus c2 sine of beta x. So this will be the solution for imaginary roots. So these are the non-repeated roots. When the roots are repeated twice, the solution will remain the same, that is e raised to alpha x will remain the same, cos beta x will remain the same, and sine beta x will remain the same. since the roots are repeated twice, so we will multiply one constant with x. Okay, so c1 plus c2x, so here also c3 plus c4x. Okay, when the roots are repeated thrice, okay, so in this imaginary part, so only this part will change. So when the roots are repeated thrice, the part which is going to change c1 into c2 plus c2x plus c3x square, and this will become c3 plus c4x plus c5x square. So as you can see here, you have to just change the constant part when the roots are repeated, and the solution will be exactly same as for non-repeated roots. So this is how we find the complementary function.